All right, boys and girls, welcome to our fourth video lesson in Chapter 6, our lesson on rectangles. Here we go. Okay, there are a bunch of properties for rectangles, but many of them are not new. Okay, the definition of a rectangle is a parallelogram where we have all right angles. So a rectangle, by definition, is a parallelogram. Don't forget that rectangle is parallelogram's twin, okay? And because it is a parallelogram, all five properties of a pair also apply to rectangles. All angles are right angles, and an extra property of rectangles now, diagonals are congruent. In other words, Fi is congruent to Hg. So if we look at rectangle right here, if we know that this is a rectangle, because it is a parallelogram, we know that this is parallel to that. We know this is parallel to that. We know that the opposite sides are congruent. We know that the opposite angles are congruent. We know that consecutive angles are sup. So now we basically, what we have here is we have all right angles, because in a rectangle, all the angles are congruent. They're all right angles. And then now we also know that the diagonals bisect each other. So I'll draw that in blue. The diagonals will bisect each other. And the diagonals are congruent because it's a rectangle, so this is congruent to that, which is congruent to that, which is congruent to that. So all four of those half diagonals are congruent, and this is the midpoint right here of both diagonals. Okay? All right, rectangle games. Rectangle games, we're no longer playing reindeer games, we're playing rectangle games. So, in a rectangular park, it has two walking paths as shown. PS is equal to 180. So this is 180 right here, this length. Okay, and PR is equal to 200. So this length right here is 200. This diagonal right here in red, so I'll redraw it in blue. Find QT. We're looking for this piece right here. Well, if I know that the diagonal of a rectangle, both those diagonals are equal, and they are bisected because it's a parallelogram, so therefore QT, half of the diagonal, must equal 100. Love writing with my marshmallow. Okay, let's do this problem right here. Quadrilateral JKLM is a rectangle. That means we know that it is a parallelogram with four congruent right angles. If measure of angle KJL is 2x plus 4, so that's this angle right there is 2x plus 4, and JLK, that's this angle right here, is equal to 7x plus 5. Well, this angle right here is a right angle, so I now know that those three angles add up to 180, which means that measure of angle KJL, 2x plus 4, plus the measure of angle JLK, 7x plus 5, that equals 90. So if I combine like terms, I get 9x plus 9 is equal to 90 minus the 9 from both sides. I get 9x is equal to 81, divide by 9, x is equal to 9. Rectangle games. Okay, again, the shorthand for this, are one extra property of rectangles is that the rectangles of the diagonals of the rectangle are congruent. So if we say congruent diags yield a rectangle, we can also go the other way too, because since this is basically a definition, rectangles yield congruent diags. Okay? Looking at this picture right here, in dodgeball, a community recreation center has an outdoor dodgeball playing field. To be sure that it meets the ideal playing field for the requirements, they measure the size of the fields and its diagonals. If AB is equal to 60, we'll label that right there. BC is equal to 30. CD is equal to 60. AD is equal to 30. And AC is equal to 67. And BD is equal to 67, same thing. How can we be sure that the playing field is rectangular? Well, all the equal sides, that just gives us the idea that, that's 60, gives us the idea that it is a parallelogram. However, now if the diagonals are also equal, this is a parallelogram with equal diagonals, therefore it must be a rectangle. Okay, and please know that any quadrilateral with congruent diagonals is not necessarily a rectangle. It must be a parallelogram with congruent diagonals. Okay, quadrilateral DFG. DEFG is a rectangle. If FD is equal to 3x minus 7 and EG equals x plus 5, find EG. So FD is 3x minus 7 and EG is x plus 5. I now know that since this is a rectangle, those diagonals are equal. 3x minus 7 is equal to x plus 5. We can solve that for x. I'm going to subtract x from both sides. And I get 2x minus 7 is equal to 5. Add the 7. 2x is equal to 12. Divide by 2. Divide by 2. X equals 6. Therefore now, you can plug x in for 6, and we find that EG is 11. Okay? I want you guys to do number 6 right now. First 5 people to email me the correct answer for the measure of angle EFD. I'll give you a bonus point on our next test or quiz. Go ahead and you can email that to me now. Okay, we finally have a proof. Again, I'm not going to write out all the steps for you here, but we're going to talk our way through this proof. Prove ABDE is a rectangle. I'm sorry, given ABDE is a rectangle, so we know that ABDE, this guy right here, I'll draw him in red. This is a rectangle, so we have all the properties of rectangles, and we have all the properties of pairs. Okay? We want to now prove that AC is congruent to EC. What I'm going to do is I'm going to prove that these triangles here in purple are congruent. If I can prove these triangles right here are congruent, I can use CPC/TC to do that. So basically, my first step is going to say that these guys right here are right angles, because rectangles have right angles by definition. Because this is a parallelogram, this side is congruent to this side. Okay? Okay, now we also have given that these two sides were equal. If you remember correctly now, this side is congruent to this side. So given that all right angles are congruent, I have those two triangles congruent by SAS, all right, which now means by CPC/TC, this is congruent to that, which is what we were trying to find. So basically, some of my steps are going to be, I'm going to have givens. I'm going to have that rectangles yield right angles. I'm going to have right angles are congruent. I'm going to have that parallelograms, because a rectangle is a pair, yield congruent op sides. I'm going to have an SAS. I'm going to have a CPC/TC. Okay? Hey, we'll see you tomorrow, and have a great day, folks.